Welcome back to AI in Real World. This is part 2 of a 3-part video series. In part 1 of the series, we built a weather agent using n8n, and we ran n8n locally using Docker. We set up the basic infrastructure and connected our agent with weather and location APIs. Now we are going to level up and turn our agent into a functional chatbot using Pydantic AI, an agent framework, giving better structure to our agent and also add forecasting abilities to our agent. In this video, you'll learn why using a framework like Pydantic AI is beneficial in building an agent. We'll also see the core concepts of Pydantic AI framework and how to build an AI agent with tools and structured data models. We will add forecasting ability to our agents and add Logfire support for debugging our agent. In the third and final video of the series, we'll add user interface and voice interaction to our agent. But first, why use an agent framework at all? While we could build a chatbot from scratch, agent frameworks provide structure, reusability, and built-in tools from common tasks like tool management, memory, and logging. This allows you to focus on the core logic of your agent rather than the boilerplate. Without a framework, managing the flow of information between the user, the AI model, and the various tools can become complex and difficult to maintain. Agent frameworks provide a standardized way to handle these interactions. Now, do we need an agentic framework to build this particular weather agent? The answer is no. Because the weather agent that we are building does not have complex, undeterministic flows and does not have multiple agents to interact with. So n8n will do the job just fine. Our goal in this channel is to cover complicated real-world use cases where we would absolutely need an agent framework. So this video gives you a good basic introduction to Pydantic AI framework. Pydantic AI is a Python library that simplifies the process of building AI agents. It provides a clean and intuitive way to define your agent's capabilities and connect it to external tools. It builds upon the popular Pydantic library, which is known for its data modeling, handling, validation, and serialization capabilities. Now, Pydantic AI makes building complex agents feel easy. If only running your business was that seamless. If you're a business owner looking to automate workflows and integrate AI into your operations, book a free consultation call with us. Let us help you build AI agents that work for your business. Link is in the description. Now let's go back and make this weather agent smarter. Let's break down the core building blocks of Pydantic AI agent. First, we got the agent, the main class that orchestrates the interactions between the user, the language model, and the tools. It receives the user's query, decides which tools to use, and generate a response. Agent will also know which LLM model we will be using. Next, we have tools, functions that the agent can use to interact with the outside world, such as fetching data from an API or performing calculations. Tools provide the agent with real-world knowledge and capabilities. This is very important because LLMs don't have real-time information. The entire code for this project that you see is in our public AI in Real World GitHub under the project Pydantic Agent. You can find the link to the complete source code in the description. Also, this code is inspired from the Pydantic AI documentation example, specifically the weather agent example. Clone the repo in VS Code, and all the needed dependencies for the project are documented in the requirements file. Open a terminal and run pip install-r requirements.txt to get all the dependencies installed. As a good practice, use a virtual environment. Check the README file which has all the details. Now let's dive into the code. We are importing async IO for asynchronous operations, since we'll be making API calls, and OS to handle environment variables, data classes for defining data structures. Then we got Logfire that provides insights, traces, and overall observability for our agent. And finally, HTTPX is an async HTTP client for making API requests. And crucially, we import agent, model retry, and run context from Pydantic AI. Agent is the core class for defining our AI agent. Model retry allows us to handle API failures gracefully and retry requests. And run context provide a context object accessible within our agent tools, which is what we will be defined next. Finally, load.env loads API keys from a .env file, which is a best practice for security and configuration. You need to define the secrets for weather API, location API, OpenAI, and Logfire. Here, we initialize Logfire. By default is configured such that nothing will be sent if a token is not present. More on Logfire later. Next, we define dependencies data class. This holds the dependencies our agents will need: an async client for making HTTP requests, a weather API key, and a geo API key. Using a data class makes it easy to manage these dependencies and pass them to the agent. Now let's create our weather agent. We instantiate the agent class passing in the model name. We are using OpenAI GPT-4o, but you can swap it out for another model. A system prompt to guide the model's behavior and dependencies we just defined. We have specified retries equals to automatically retry failed API calls. The system prompt is crucial. It instructs the model to be concise and always includes the temperature in its responses. This helps to control the agent's output. Next comes tools, and this is where the magic happens. We define our very first tool, getLatLang, using the tool decorator. This makes the function available to the agent to use when needed. It takes a location description as input and returns a dictionary containing the latitude and longitude. Notice the context parameter. This gives us the access to the dependencies we defined earlier, like the geo API key and the async client. We can access it with context.dependencies. The function itself is pretty easy to follow, and it returns latitude and longitude of a location. The getWeather tool is similar. It takes latitude and longitude as input, uses the weather API key to make an API call to a weather service, tomorrow.io in this case, and it returns a dictionary containing the temperature and weather description. Next, we got the forecast tool. The getForecast tool follows a similar pattern, but instead of getting the current weather, it retrieves an hourly weather forecast for the next 5 days. This tool demonstrates how to process more complex data structures returned by an API. We iterate through the hourly data in the API response, extracting the temperature and weather description for each hour. This data is then compiled into a list of weather data dictionaries. The function getWeatherDescription takes the weather code returned by the API and maps it to a human-readable description. It is a straightforward lookup using a dictionary. Finally, we got the chat function, which creates an interactive chat loop where the user can ask weather-related questions. It takes the weather agent and dependencies as input. Inside the loop, we take the user agent and run the agent using weatheragent.run. This triggers the agent to process the user's queries, potentially using the tools we defined earlier. Notice the message history parameter. This allows the agent to maintain context across multiple turns of the conversation. We are using the allMessage function to get the history and keep track of previous exchanges. And remember, before you're ready to run this program, remember to get your own API keys from tomorrow.io, geocode.maps.co, and set them as environment variables. You also need an API key from OpenAI and Logfire. Let's now see the chatbot in action. To run the chatbot, open a new terminal and just say python weatheragent.py. Execute. All right, let's ask a question. I'm going to ask, do I need a jacket tomorrow in Chicago? And we got a response back, which is, yes, we need a jacket in Chicago tomorrow, and along with the temperature for tomorrow. And as you can see, the chatbot correctly determines the location, fetches the weather forecast, and provides a helpful recommendation about whether or not to wear a jacket. Let's now break down what happened behind the scenes. The agent first received the query, do I need a jacket tomorrow in Chicago? It then used the getLatLang tool to get the coordinates for Chicago. Next, it used the getForecast tool to get the weather forecast for Chicago tomorrow. Finally, it used the language model to generate the response based on the forecast, advising us to wear a jacket. See, it didn't take a lot of code to turn this weather agent from N8N to Python using a framework like Pydantic AI. The framework is pretty easy to use, removes all the boilerplate code that we need to add, and gives a pretty good structure to our code. And Pydantic AI integrates seamlessly with Logfire, a logging and monitoring platform for AI applications. As a matter of fact, Logfire is also from Pydantic. And when we ran the weatheragent.py script, you will see a Logfire project URL in the output. To configure Logfire, first create a free account from Logfire Pydantic website and get the keys and put the key in the .env file. Now let's check out Logfire. Once you open the Logfire URL in your browser, you will see the detailed logs of the agent's execution. And this can be extremely helpful for debugging and understanding how the agent is making decisions. For example, this log shows you the exact query with parameters that was sent to the weather API. Here you can see the latitude and the longitude being passed and also the response that you received from the weather API. Information like this will be extremely helpful to debug issues with your API calls. And as your AI applications become complex in its interactions with tools and other agents, this type of observability with Logfire becomes very essential. Alright, in this video, we took our basic weather agent and turned it into a chatbot with Pydantic AI. We added forecasting abilities and learned how to use Logfire for debugging. In the next video, we'll build a user interface for our weather chatbot and add voice interaction using Streamlit. If you're excited about the possibilities of AI and want to explore how it can transform your business, don't hesitate to book a free AI consultation call with us. We are here to help you every step of the way. The link is in the description, and thank you so much for watching. See you in the next video.